So this is your warm-up. You're supposed to be writing it on the warm-up sheet in Thursday's box. So I'm going to transfer there. So 2x plus 4y equals 12 is the first one. 2x plus 4y equals 12. And then the second one is 3x minus 5y equals 10. Okay? And then I'm going to just separate them because I'm OCD. No, you're just supposed to rewrite both of them in slope-intercept form. Obsessive compulsive disorder. Okay, here we go. We're trying to get into slope-intercept form, which is y equals mx plus b. So to do that, what do we have to do first on this one? Correct. That's my mx. It belongs on that side, so we're going to subtract it so that it can be moved over there. It then cancels out on this side, and you have 4y equals 12 minus 2x, or we might as well go ahead and write negative 2x first and positive 12 second. And why is that? Right, that's mx plus b. So you might as well go ahead and reverse the order of those. Now to get it in y equals mx plus b form, what do we need to do? Right, they're being multiplied, so the inverse of multiplication is division. And now we have y equals, we're going to reduce this. Negative 2 over 4 will reduce to, but remember, you're right, but we want to keep it as a fraction because if we went to graph this, you need a rise and a run. So yeah, whenever you're doing slope-intercept form of a line, you need to keep your m as a fraction so that you know the rise value and the run. If you just have 0.5, you won't have any idea where to go to get to the next point. Okay, and then what does our b become when simplified? Positive 3. Okay, so that one's done. Over here, what do we do? Subtract 3x. Those cancel, leaving negative 5y equals what? Right, negative 3x plus 10. Now what do I do? Divide by negative 5. And so I have y equals a negative divided by a negative is positive. So those signs just cancel each other out. 3 divided by 5 cannot be reduced, so you're just going to keep it. 3 over 5x. And then 10 divided by negative 5 is negative 2. Now, can anybody tell me how many solutions this system would have if you took the time to graph it? 1. How do we know that? Well, they're not the exact same line, right? And they don't have the same slope. If they were the exact same, m and b, they would be the exact same line, and that would be infinitely many solutions because they would just be on top of each other and cross over and over and over. If they had the exact same slope, they would be parallel. Since everything's different about them, they're totally different lines, which means they'll intersect once. Okay, now we are going to do a note sheet today. All right, so we're working on what we were learning yesterday. We're just going to do a few more problems together, and then you're going to work some on a worksheet by yourself. Okay, example 1. We're going to be graphing a system of equations, which is when you have 2 or more, but for right now we're just dealing with 2 equations. The first equation is y equals negative 1 over 3x minus 4. And the second equation is y equals 1 over 3x minus 2. Now remember, the directions are to graph them. Are they ready to be graphed? Yes, so we can go ahead and identify the slope and the y-intercept of each one. What is the slope of this first equation, the pink one? Negative 1 over 3. What is the y-intercept? Okay, so to graph it, where do we put our first point? On the y-axis, because it's the y-intercept. And then to get to the next point, what do we do? down 1, right 3. Okay, and it makes sense that our line is going down because our line has a negative slope. Now, we could also do that one more time, down 1, right 3. And then if we wanted some points this way, what else could we do? Up 1, left 3. Up 1, left 3. You can do that a couple of times. Now that you've got as many points as possible, you're going to use your ruler to connect them with a straight line. They're up here on this front desk. I'm just going to try it for this unit and see how it goes. I really... All right, let's get back on topic. For the green equation, what is its slope? Right, positive 1 over 3. What is its y-intercept? So where do I put its first point? Negative 2 on the y-axis. And then to get to the next point, what do I do? Up 1, right 3. And then I can do that again, up 1, right 3. Or I could have also gone and look, the first time I did that, what happened? I intersected the other line. Okay, so go ahead and use your ruler to connect those points. Okay, so we just saw that there is one solution. Where is that one solution? Negative 3, negative 3. Now, we obviously see why it's the solution because it's the point of intersection. Graphically, that's why. Can anybody tell us algebraically why this is the solution? No, think about what we did yesterday. Okay, look, if I rewrite both equations up here, y equals negative 1/3 x minus 4, and y equals positive 1/3 x minus 2, and I'm using this point, this is the x value, this is the y value, right? So in both of the y places, I'm going to plug in a negative 3. In both of the x places, I'm going to plug in a negative 3. Now use your calculator and type in this right here, negative 1/3 times negative 3 minus 4. Go ahead and type that in. Okay, when you type in negative 1/3 times negative 3 minus 4 and hit equals, what does it say on your calculator? Oh, no. When you typed in negative, okay, let me type it in. Yeah, you can put either. Okay, watch, I'm going to type it in. Okay, alpha y equals, to set up the fraction, negative 1/3, and then I do use the parentheses, and I'm plugging in a negative 3 for the x, and then minus 4. And when I hit equals, it says negative 3, which is what it should equals negative 3. So see how it worked when I plugged in negative 3, negative 3? This point, it worked for this equation. Now we're trying it in the other equation, this one. So type in positive 1/3 times negative 3 minus 2 and see if it equals negative 3. Okay, I'll type it in. Okay, so look, I'm going to type it in too. We got a 1/3 times a negative 3, and then this one ends with a minus 2. Oops. And it equals negative 3 as well. See how this point worked in both equations? That's why that point is the solution to the system. Do you think there's another point that will work in both equations? No. Okay? Listen, there are an infinite amount of points that will work in the pink equation. And there are an infinite amount of points that will work in the green equation and make them true. But there is only one point in the whole world that will work in both, and it is this point, the solution to that system. Yep. Okay, so now that we see that we have exactly one solution because they only intersect once, does that make this consistent independent, consistent dependent, or inconsistent? Consistent independent. Consistent independent is when there is exactly one solution. Okay, because think about it. Will these lines ever cross each other again? No, because lines don't curve and come back. This one will forever go that way, and this one will forever go that way and that way. So they will never intersect again, meaning this is the one and only solution these lines have. This is the only x and y value that when plugged in both equations will make both statements true. Nothing else will. Okay, let's try example 2. This time your first equation is negative 3x minus y equals negative 2. And your second equation of the system is negative 3y equals negative 12 plus 9x. Now remember, our directions say graph the system, but are they ready to graph? No. So over here to the right of the graph, you have some room where we can do some scratch work. So we're going to take that first equation and rewrite it in slope-intercept form, just like we were doing on the warm-up. So what do I do first? Add the 3x to cancel it on the left and move it to the right. Now on the left, I have a negative y. And on the right, I have negative 2 plus 3x or 3x minus 2. Just go ahead and put it in mx plus b order. Now do I have it in slope-intercept form? No, why not? This is a negative 1 that's being multiplied by y. So to undo multiplication, we divide by negative 1. Those cancel, leaving y by itself. 3 divided by negative 1 is negative 3x, and negative 2 divided by negative 1 is positive 2. Now that it's in slope-intercept form, you're able to identify the m and the b. What is the m? The slope. So negative 3, and since it's a whole number, over 1, so that we have a rise and a run. What is the y-intercept? 2. Okay, now we have to do the exact same process with that second equation because it is also not in slope-intercept form. So bring it to the side where we have some room. Now look, while I'm writing it over here to save time, can't I go ahead and flip-flop the order of the mx and b, put the 9x first and the negative 12 second? And now the only thing I have left to do to get it in slope-intercept form is what? Divide by the negative 3. And so I end up with y equals what? Plus 4. So my slope is, and my y-intercept is, okay, so now let's put them on the graph. For the pink line, where do I put my first point? 2. To get to my next point, I go down 3, which way over? Right 1, because we want this line to be going down because it's a negative slope. And then I can do that a couple more times. Down 1, 2, 3, right 1, down 1, 2, 3, right 1. I could have also gone up 3 and left 1. Okay, then connect those points to make a line. Because without that line, it's just points. You have to connect them. But actually, it's lineless. Because if you don't put the line, the points are there. I'm just saying the points are there, so it's not pointless. Okay, now for the next one, for the green equation, where do I put my first point? 4. Then what do I do? Down 3, right 1, down 3, right 1, down 3, right 1. What are you discovering? They are parallel. How could you have already known that before even graphing them? They have the identical slopes. Anytime their slope, their m value is the same, they're going to be parallel. Because think about it, if they consistently go down and over by the same amount every time, they're never going to intersect, which means they have how many solutions? No, none. No solutions. What does that make them? Consistent or inconsistent? Inconsistent. Zero solutions? You can, but you would need to write out zero solutions, because if you just write zero, it's almost like you're trying to say they intersect at zero. You know what I mean? You got to be careful about that. Okay. Example 3. It's on the back. Yeah. If this is together, y'all are going to have problems by yourself in a minute. Okay, 8x plus 3y equals negative 12 is our first equation. And then our second equation is 0 equals negative 12 minus 3y minus 8x. Okay, are they ready to be graphed? No. So over to the side where you have some room for scratch work, let's rewrite the first one into slope-intercept form first. So what do I need to do? Now I have 3y equals negative 12 minus 8x, or negative 8x minus 12. Now what do I need to do? Divide by 3. And I'm left with y equals, well, can I reduce that fraction? No, so it's just negative 8 over 3x. And then can I reduce the y-intercept to a negative 4? Okay, so now for the first line, my m is negative 8 over 3, and my y-intercept is negative 4. So where do I plot my first point? And then from there I go, correct. It tells us to go down 8, right 3, but we will run off the graph. So instead we go up 8 and left 3. And then that's as many points as you can fit on there. Okay, so go ahead and connect them. Okay, and now it's time to rewrite the second equation, the green one. Okay, now keep in mind, our goal here is to get this in slope-intercept form, which is y equals mx plus b. So the mx and the b belong on the right side of the equal sign, and the y belongs on the left. So what's the easiest thing to do? Right, move the 3y over, and since it's minus 3y, to cancel it, you add 3y. So now on the left, you have that 0 plus 3y, which just becomes 3y. Hold on, my OCD is telling me to switch back to green. Okay, so we have 3y equals negative 12 minus 8x. Okay, now what can we do? Divide by 3, because we're trying to get y by itself. You don't want to add 8x. It's on the correct side of the problem. So now y equals negative 12 over 3 is negative 4. And then can you simplify that? Okay, and so now many of you will be able to look at that and identify the m and the b. But it might be helpful for you to go ahead and put them in order. That way you don't mess up when you're identifying the m and the b. Just remember, the m is always the number beside the x. The b is always the constant value, the one that doesn't have a letter. Right. The m is negative 8/3 again, and the b is negative 4 again. So when you graph it, isn't going to be the exact same graph? Which means it has how many solutions? Many, infinitely many, because think about it. Solutions are created when points intersect. Well, isn't every single point going to intersect because they're the same line? And what do we call that? Consistent dependent. Okay, now I'm about to pass out a worksheet that you're going to work on by yourself. I'm about to pass it out. You're going to be working on pages 1 through 4, odd. Please do not think you're going to go ahead and do the evens, because tomorrow we're going to use the evens and I'm going to teach you a different way to do this. So we'll be using those problems with the new way. Okay, so just do the odds today. There's